In this work, we present the concept of environmental constraints in human and robot grasping. We will show sample grasps that derive their robustness from the exploitation of such constraints. Here, the object itself serves as a visual constraint to align the hand above it. During the downward movement, the table surface realizes a haptic constraint that indicates the termination of this motion. Subsequently, the table surface is used to constrain the motion of hand and object, while the edge is a visual constraint that detects when the book protrudes it. Finally, the thumb can enclose the object to form a stable grasp. The way environmental constraints are exploited may differ from hand to hand. The highly compliant RBO hand can use the table surface to position itself close to the object. Then, by flexing its fingers, the object is pushed against the palmar pad, establishing force closure. Along the way, the table constraint guarantees that the object cannot escape. A similar strategy exploits an edge constraint, as seen here. This is useful for grasping smaller objects. Here is an example of an even more complex exploitation scheme. The RBO anthropomorphic hand first pushes the object towards a corner, where it uses a wall constraint to slide its fingers underneath it. Finger flexing and wrist rotation complete the grasp. That this scenario is not at all artificial can be seen here. The same strategy as before is used to grasp a chocolate bar placed inside a drawer. All these examples showed that the successive exploitation of environmental constraints leads to robust, reproducible grasps.